Inside every electric vehicle, there's this one part that works harder than pretty much anything else, but it gets almost none of the credit. We're going to pull back the curtain on this unsung hero, a component that is fighting a constant battle against insane temperatures and incredibly complex electrical demands. Okay, so if I asked you right now to name the most critical part in an EV, what would you say? Your mind probably goes straight to that huge battery pack, right? Or maybe the super powerful electric motor. Yeah, those are the rock stars, the ones that grab all the headlines. But the real answer, the part that's quietly become the absolute linchpin for the entire vehicle, well, it's probably the last thing you'd ever guess. We are talking about the electric compressor. And trust me, it's no longer just about keeping you cool on a hot day. Its job has become way, way more critical. I mean, for ages, a compressor had one job, and one job only: power the air conditioning. Simple. But in an EV, it got a major promotion. It's now the literal heart of the vehicle's thermal management system, and it's responsible for keeping every important component at its perfect operating temperature. I mean, just look at this. The job description just exploded. It used to be so simple, just one task. But now it's fighting a war on 3 fronts. It still has to cool the cabin for us, of course, but now it also has to manage the battery's temperature, which, let me tell you, is absolutely critical for performance and how long that battery lasts. And it has to cool the electric motor. Its workload has literally tripled. But, with all that new responsibility comes a whole lot of risk. This compressor has to survive in one of the most electrically complex places you can imagine, and that's where we hit our first huge challenge. So think about it this way. The compressor has 3 main lifelines. You've got the high voltage power coming from the main battery, you've got low voltage power for its control circuits, its brain, and you've got a communication line so it can get its orders. Now, the key thing here is that all 3 of these are on a shared network with a bunch of other components. This means the compressor has to be a perfect neighbor, operating without creating any electrical noise or interference that could mess with the rest of the car. And it gets even trickier than that. It's like this super delicate digital handshake. The high voltage and the low voltage power, they turn on and off separately. If that timing is off, even by a millisecond from what the car's main computer is expecting, it can cause a glitch, or worse, a total failure. Getting that sequence right is everything. Okay, so to handle all this high-stakes electrical drama, every modern EV has this silent guardian, a safety inspector that's on duty 24/7, constantly watching the whole high-voltage system for any sign of trouble. And here's basically how it works. The car is always measuring insulation resistance. If everything's A-OK, resistance is high, no problem, nothing happens. But if it starts to detect a little leak, you get a warning light on your dash. And if things get serious, where that resistance drops way too low, the system can take drastic action. It might even cut off the high voltage power entirely to keep everyone safe. So the takeaway here is massive. That compressor has to be perfectly insulated, no ifs, ands, or buts. So, on top of surviving that whole electrical gauntlet, the compressor is also living in a world of total temperature extremes. We're talking brutal heat and freezing cold. 80 degrees Celsius. Let that sink in for a second. That is 176 degrees Fahrenheit. And that's not the air temperature outside, no. This is the searing heat inside the engine bay on a hot day that the compressor has to operate at. And that crazy heat, it has a very real, very direct consequence. It's why summer is by far the peak season for compressor failures. Heat is its #1 enemy. So you've got these 2 challenges, right? Complete polar opposites, but both are incredibly tough. In the summer, it's got to survive that blistering 80-degree-plus heat, and sometimes it has to cool itself down before it can even start cooling the battery. But in the winter, the refrigerant oil inside gets all thick and goopy, kind of like molasses. That creates huge mechanical resistance, and it takes a massive jolt of power just to get the thing started. And if all that wasn't enough, the compressor can't just have one on switch. Nope, it has to master 2 totally different ways of starting up, all depending on the situation. First up, you've got the cold start. The car's been off, pressure in the system is low, and the goal here is finesse, a smooth, quiet start that you, the driver, never even hear or feel. Then, on the flip side, you have the hot start. The system pressure is high, and this requires brute force. The compressor needs a powerful, heavy load startup to muscle through that pressure and get things cool fast. So it has to be a ballet dancer in one moment and a power lifter the next. It's got to do both. So how in the world is this little unsung hero keeping up with all these crazy new demands?
Well, the answer is pretty simple, actually. It's getting faster, and it's getting bigger.
All right, first, let's just talk about speed. To get more cooling power without making the part itself physically huge, compressors have had to start spinning way, way faster. We're talking operating speeds have basically doubled, with the latest ones hitting up to 8,000 RPM. And it isn't just about spinning faster. To manage the incredible heat from modern EVs, they're also getting bigger in terms of displacement. That's just how much refrigerant they can push through. So the bottom line is pretty clear. As our EVs get more powerful and kick out more heat, this little guy has no choice but to level up right along with them. Its job is only getting tougher. And that really leaves us with one big question, doesn't it? As batteries charge even faster and motors get even more powerful, putting more and more stress on this whole system, what's the next insane challenge this tiny hero is going to have to conquer?